Hello, Interact Fellowship. I'm here to just give a quick crash course on just, basic audiovisual terminology, learning about just basics for sound and lighting. And, when people talk about all this stuff, you'll have an idea of what's going on. So, this should be used for training purposes. It's just a quick crash course overview of what I think is important for AV stuff. All right. So first we'll go over the table of contents. First we're just going to go over AV 101, which is the basics. Then we're going to go over some signal flow for both sound and lighting. I already have a video on that, but this will just be a quick overview of that again. Pro Presenter, it'll go over the basics, what I think is the basic most necessary. So like a crash course of the crash course video I made already. Patching, how to literally do the patching. Like I'll probably give you visual demonstration of how to do the patching. If, it's just signal flow in action, so you see what signal flow actually looks like in real life. Awana, what we do for Awana stuff, how we set stuff up, and what we are expected to bring whenever we lead worship for Awana. And then common issues, things that might bring up problems for either audio, visual, or projection. All right, first let's start with AV 101, just some basics and some terms. So first I'm going to start with mono and stereo. So you might hear this a lot if you're doing audio or any tech stuff. If something's mono or something's stereo, basically for mono, right? It combines all the audio into one, so you won't be able to tell which direction it's coming from, right? If it everything, no matter if it's on the left side or the right side, or if it's the right side audio, left side audio, it'll just combine into one, and it'll just play through both speakers, and you won't know which one it is. Stereo is that it'll split in between two tracks. There'll be a left track and a right track, and you'll play both lines through a right and left speaker. So as you see here demonstrated, right here, mono would only have one basically essentially feels like it's one speaker because all the audio is going through the speaker, versus if I have something turned to the left side or something turned to the right side, it will only come out one side, right? Stereo basics. All right, next. All right, most audio cables, lighting cables, and just cables in general have two sides. They have a male end and a female end, right? So I feel like it's pretty self-explanatory. The male end would have 3 prongs, and the female end would have 3 inserts. All right. So here are some just common cables I'm going to go over. The first, XLR, DMX, Speak on cable, TS, TRS, TRRS, RCA, and PowerCon. These are the cables that I think are most important. All right, so this is a XLR cable, right? You can tell by the 1, 2, 3 pins it has, right? It looks like this. This is for audio. Anything that is required with audio will be using this kind of cable, and this is an XLR. So if anyone ever says XLR, it is this kind of cable. All right. So this is a DMX. So you might think it looks really awfully same to XLR, or you might notice there's 5 pins in this one, and it's different. Well, the thing about DMX it's kind of tricky is that there are 5-pin versions of DMX, and there are 3 pins. So the 3-pin would look exactly like this. It would look the same. The only way you can tell is either like they're usually labeled on the cable somewhere that says DMX somewhere along this line, or you just know, right? But the 5-pin ones are definitely always DMX. DMX is for lighting. So you can use a DMX cable for audio, although it is not the best, but you cannot use an audio cable for lighting. That's because these DMX cables are more expensive because they're more shielded. They have more protection so that they won't pick up any electrical signals from all the power going through all the lights they're dealing with, and just a lot of cabling around it. So they're more shielded, more expensive, and they're different and very different purposes. All right. Next, we have PowerCon. This is called a PowerCon cable, and generally what this is used for is just to bring power, right? You can use it to bring power to your speakers. You can use it to bring power. More generally, people use it to bring power to the lights, because a PowerCon cable it just sends power. It just sends electricity. There is a version of PowerCon cable where one side is this and the other side is a plug, and it goes directly into the wall. And that's usually how you start a chain for PowerCon cables. You plug in from one light to another, right? And then we have an audio-specific version. It's called SpeakerCon. SpeakerCon, you can actually run audio signals through it, and you can just plug it directly, one in the speaker, one into the soundboard, and it will bring power to the speaker. I'll explain that a little bit later on why some speakers need power and some speakers don't. But yeah, so this is called a speaker-on cable. It's different from the power-con. Power-con is made for general use of electricity powering. Speaker-on cables is for audio-specific power. It can also send audio signals. All right, so this is the TRS, TRS, right? There's a difference. So you might see these cables and you might hear it by the common name. A lot of people call these ones 1/4 inches because, it's 1/4 inch thick. And this is called an aux cable, which is, what you plug into your computer or maybe your phone. So the reason we call them TS or TRS or TRS is the T stands for tip, right? All of these three have a tip, so that's a tip. Ring. This one doesn't have a ring. This one has one ring, and this one has two rings. So that's why it's TR, and this is TRR. Sleeve is this part right underneath. This is called the sleeve. So that's why these cables are technically called TS, TRS, TRRS. Or, you could just know them by 1/4 inch length and then aux. But it's good to know what they're actually called. All right. And then we have the RCAs is just we have the left and right for audio. You plug these into your soundboard. We don't use them as much. We used to use them on TVs a lot more in the past. But nowadays, most audio's gone through either like just an aux cable or HDMI. So these are mostly irrelevant, but we do use it for convert this into an aux into a computer sometimes. It's not as often. All right. So next, when people talk about often is snake. It's got to do with XLR cables. When they say snake, they're not referring to like the snake. If someone's like, "Oh, can you grab me the yellow snake?" It's not like they don't want you to go to the jungle and grab a snake like this, okay? They want you to grab something that looks like this, and it's probably labeled yellow. That's why they call it the yellow snake. And it's basically just a bunch of really long XLR cables tied together to save space and to create less tripping hazards. So instead of, there's like 8 inputs here, instead of having, 8 XLR cables that are like 50 feet that are tripping hazards, you just have one cable that's tripping hazards. So only one person has to trip over it. All right. Next thing, balanced versus unbalanced. So what's the difference between balanced and unbalanced, right? So clearly these two right here, they're different. So one has only one and one has both, right? So this is a negative, and a positive, right? So what this means is that unbalanced, basically, it just has less protection from electrical sound. So if I put this next to like electrical cable, it's more likely that I get like a random buzz sound into my speakers if I'm using this kind of cable. Versus this second line will counteract whatever, electrical signal is going around it. So it will not create that buzz in general. So that's why usually if you hear electrical noise or something like when you're playing through speakers, it's probably because you have an unbalanced cable that's touching some like electrical cable somewhere in the ceiling or something like that. You don't want that, which is why most people, prefer to go with like a balanced cable. So a balanced cable is like an XLR, DMX, they're all balanced cables. And an unbalanced cable is like a TRS. Right, a 1/4 inch, an aux cable. They only have one of these lines running through it, so they are unbalanced. Oh yeah, and this mesh you see around is copper shielding. It's also meant to help protect from hearing like audio noise, but it's not perfect, so you can still hear it sometimes, but it does help. And what DMX has more of this copper shielding around it than XLR or 1/4 inch TRSs do. All right. So now, DI boxes. So we've heard of this, talked about this last time a little bit, but here it's more clear, right? It converts from unbalanced into a balanced cable. It turns from, electrical signals that could be messed up. You would plug your guitar in on this side, and usually there's no electrical cables running like near your guitar usually, unless you're playing like an electric guitar, but usually you wouldn't have to worry about like having electrical cables running on stage to mess up with the unbalanced cable, and then you have it going out of a balanced cable to go all the way around to the back and not have issues even if it's near electricity because it has more protection. Right here is called padding. I'll go over padding a little bit more But DI boxes also have two versions. This one right here was the one that we use. It's a passive one, and there is an active one, and which I'll explain to in a moment. All right, this is our soundboard. This is the mixer that we use. Either soundboard or mixer. Yeah, understanding it is it's not too difficult, but I'm not going to go over it right here. If you want to know more about this, you can ask me about it, and I can explain it. But yeah, just know this is our soundboard. This is our mixer. All right, here I'm going to explain some really important things I think need to be talked about for audio stuff: active and passive, gain, phantom power, standby, faders, and padding. All right, passive or active. So passive or active. Usually when something is referred to as passive or active, it means does it require power or not? If it's passive, it doesn't require any power. If it's active, then it requires somehow a source of power to enter it. So that can go for guitars, bass guitars, electric guitars. Most of them are passive, but some of them might need a battery. They might have a battery in it. So for example, our guitars and our bass, one of our bass and all our guitars that are able to be plugged in are all active, right? They need a battery inside. And if you don't change the battery, you might, cut out a lot, or it just won't work at all through the audio system. Passive, right? Passive was just like the other bass, you just need to plug in and you don't need to change the battery, nothing, you don't need to worry about it. It just doesn't need power. So the DI box that I showed earlier is a passive DI box, so it'll work even whether or not you give it power, versus an active DI box, which is better. It sounds better and it just works better. Like it just functions a lot better than the passive one, but it's more expensive, but it would also require power from the soundboard or something else to send into it. All right. So gain. So what exactly is gain? Gain is basically just how much sound you let into your soundboard system. Your audio comes in through your microphones into your soundboard, right? And you don't really have control of how much audio is going in because that's based on how loud the singer's singing or how loud the instrument's playing. So this is your first gate. This is your first control point as it's entering the soundboard, where you can control how much of the audio you let in from, whatever's going on stage. All right. This is called phantom power, right? Phantom power, you'll see usually a red dot. That generally indicates that it needs phantom power, something that has a red dot like this. It'll say 48V, or it'll literally just say phantom power. So what is phantom power? So like I said, some DI boxes and other things like microphones require power to run because, it's too big it just requires power to run and it can't run passively on its own. And what this does is that it sends 48 volts of energy back into the XLR cable straight into whatever channels you're sending whatever channels you're sending the power into. So like a microphone on channel 1 might need phantom power. Turn it on and it'll send 48 volts into that microphone, and then that microphone will work. Without the phantom power, it won't work. Same with certain DI boxes. All right. Next, standby. On our soundboard, it's a standby button where it mutes channel 1 through 12 automatically when you press this. So even whether or not channel 1 through 12 are muted on their own, this will override the mute. It's like a master mute. On most modern soundboards, you'll just have a mute button over your main. On this one, the one that we have, you don't. All right. Faders. So you might see this a lot. This is a lot of people when they think of audio or audio, they think about this stuff. What is this, right? So this is how much audio you let out. So once you have controlled the gain, the audio that goes through your soundboard, this is the end. This is the very bottom where it lets out the audio back into the speakers. So how much you control. So if you're at 0, which is generally what you want to be at, it means you're not changing. It's just going straight through the soundboard. Whatever's coming through the gain is going throughout straight away. If you want to bring it down, you can bring it down, like for example here 60 decibels, or you can bring it up 10 decibels, but that's only if you need to, right? Normally you want to keep it around this range. That means you have more control and you gained it properly while you were practicing. And of course you fade them up and down. That's why they're fading, but yeah. Next, padding. Okay, so if someone's too loud or something, it's like the instrument itself is too loud or someone's too loud, you can do this thing called padding. Padding basically it subtracts automatically anywhere from like 10 to 20 decibels. Based on whatever device you're using, it might have a pad on it or not. So for example, if we go back to this, You see, you have a 0 decibel pad, a 20 decibel pad, and a 40 decibel pad. It'll be different for everything. Some soundboards, for each channel, you can have a different amount of pad to just basically bring it down that much audio level, and then you have more, so that you have more control over the sound going in and out. All right. So now I'm just going to go over some common. Now I've gone over like audio and like lighting cables. I'm going to go over some common video cables. These are ones that are more modern, more important. All right. First of all, VGA. This is old. Okay. The nice thing about VGA cables is that they're like, okay, they're not as common now, but they used to be common and found on everything. They would be plugged into everything. And you see these little screws here? They would screw into whatever they're plugging in. And then it's either the best thing or the worst thing because it takes forever to unscrew, but then also it never falls off because it's literally screwed into whatever device you're using. So that was nice, but also it got annoying. So this is the old. So this is also old. It's called DVI. It's better. It's just literally better. It's just better than VGA. You know, a lot of computer screens or whatever, a lot of things came with this kind of display, this display cable. But this is also old. It has the screws. It's annoying to deal with. It's annoying to take on and off. But, you know, it was better quality than VGA. Now, the most common thing we use nowadays is called HDMI. It looks like this, right? Kind of like a trapezoid. This is very easy to take off, but also it's very loose, so sometimes it falls off, which is the most annoying thing about HDMI. But it's most common, it's simple to use, everyone uses it, and it can also send audio through it. Alright, so this is called a display port. It's a little bit different, you know, it's also technically a trapezoid, but this edge is a straight edge. It's less common, but it is the better cable. It is the better version of HDMI, essentially, where it just works better. It sends better quality, and it generally, a lot of them have like a little push bar here so it doesn't fall off. Like you have to push it to take it off, which, you know, it's still very easy to take off compared to having to unscrew two screws like with a VGA or a DVI, but it's also like, you know, yeah, just better version of HDMI in my opinion, but it's more expensive, so it's less common. Then we have Thunderbolt. This is like an Apple thing. Some PCs also have it, but like mostly Apple, Macs, whatever use it. It's just another kind of display cable that usually Macs have. We use one, but we use a converter from this into an HDMI or a VGA. So, yeah. USBs. There's a lot of kind of USBs. There's 3 kinds of USBs, A, B, and C. I'm not going to talk about B because it's not really important right now. The most common ones are USB-C and USB-A. You might notice that USB-A here, they have like different colored like insides. You don't need to worry about it. That's like, if you're interested in why that is, you can, you know, ask me about it or you can look into it. But just know it doesn't really matter. It's like very unlikely to be the problem of like the issue that you're having if you're using like an older version of USB. But this is a USB-A. This is pretty obvious. You probably see this and use this all the time. Same thing with this, right? Even, and especially if you have an iPhone 15, this is the new charger for this. But these are both cables that you can, you know, plug things into. Yeah, they're just useful. Yeah. So I think that's it for like just the basics 101 for, you know, like audiovisual basic like terminology and important things I think that you guys should know.